Hey guys, I'm going to run through the 7.4 homework, which is the last homework assignment for chapter 7, and it talks about infinite geometric series. So in the previous one, we talked about finite geometric series, and then, this one's infinite. So consider the infinite geometric series. Find and graph the partial sums S sub n for 1, 2, 3, 4, and 5, and describe what happens to S sub n as n increases. So here is the series. Now, so find S sub n for n equals 1, 2, 3, 4, and 5. So S sub 1 would be equal to the sum of the first term, which would be 1/2. S sub 2 would be equal to 1/2 plus 1/6. So if you don't want to use fractions, so 0.5 plus 1/6, and I get 2/3. Sorry, I saw it in the calculator and it's 0.6667 repeating, so then it's just 2/3. And then S sub 3, now to find S sub 3, I would add the first 3 terms. Or what I could do, since this right here was S sub 2, I could just take this and add 1/18. So 2/3 and add 1/18, and I get 0.72222, so 0.722 repeating the fourth. And then if I want to find the so again, these are partial sums, so meaning what is the sum of the first term? This would be the sum of the first 2 terms, this would be the sum of the first 3 terms, this would be the sum of the first 4 terms, or I can just take this number and add the 4th term. So then I'll add 1/54, and I get 0.7407, and all of that is repeating. And then there's a typo here. This should be 162. And then I'm going to take this number right here and add 1/162. And I get that S sub 5 is equal to 0.7469, so on and so forth. And then if I graph these numbers right here, so the first one is 1/2, and then the second one's going to be 2/3. And then next one, 3 is 0.72, so maybe something like right here. And then the next one would be something like right here. And then the next one for 5 would be closer to 7.5. So what's happening to the S sub n as n increases? I think it's getting closer and closer to 7.5. So I'll say S sub n approaches 0.75. That's what I would say. You can kind of see that that's where this is going. And that's what an infinite geometric series does. If the ratio is less than 1/2, then or less than 1, sorry, then the infinite geometric series diverges. You'll do the same thing here. So S sub 1 is going to be equal to 2/3. S sub 2 is going to be equal to 1, because 2/3 plus 1/3 is 1. S sub 3 is going to be equal to 1 and 1/6, because that's what 1 plus 1/6 would do, and 1 plus 1/6 is equal to 1.666 repeating. S sub 4 would be equal to this plus the 4th term, so add 1/12 to that, and I get 0.125. I get 1.25, so 1/4. And then I'm gonna, for the 5th partial sum, I'm gonna take that number and I'm gonna add 1/24. And I get 1.29166 repeating. All right, so if I'm graphing these partial sums, so 2/3, which is going to be probably somewhere in here, and then 1 and then 1 and 1/6. So 1 that should be a 1 right here. There we go. That makes a lot more sense. So that would put it like somewhere like right here. And then we would get here. Actually, probably be a little bit further up. And then for the fifth one, 1.29. That might just be like right here. So what does it seem to approach? S sub n, if I had to guess, would approach like maybe like 1.3, maybe higher. Can't really tell for sure right now, but that's where the infinite series seems to be approaching. So hopefully you get the idea. Go ahead and go through 3 and 4. Make a list of the partial sums. So take 4, take the sum of the first 2 terms, take the sum of the first 3 terms, 4 terms, and then 5 terms, and then graph them accordingly. Okay? All right, and then here, find the sum. So find the actual sum of the infinite geometric series. So the equation for an infinite geometric series is, you can just say S. That's going to be equal to a sub 1 over 1 minus r, where a sub 1 is the first term, r is the common ratio, r, the absolute value of r, has to be less than 1 as well. So keep that in mind. So looking here, you can see that the absolute value of r, which is 1/5, is less than 1, so we're good. The first term would be 8. I can tell because if I plugged in 1, I'm going to get 0, and anything to the 0 power is 1. So the sum is going to be equal to 8 over 1 minus 1/5. That would be equal to 8 over 4/5, which would be equal to 8 times by 5/4. And that would be equal to 10. Excuse me. All right. For this next one right here, the ratio is equal to 3/2, which is greater than 1, which goes against the rule for infinite geometric series. So we can say the sum does not exist. All right, for the next one right here, if I plug in 1, I'm going to get 0. So that means so for my sum, my first term is 11/3 over 1 minus the ratio, which is 3/8. That's equal to 11/3 over 1 minus 3/8 would be 5/8. So I get 11/3 times by 8/5 if I do the keep change flip rule. And that's going to be equal to 88 over 15. Also, sum does not exist because the ratio here is greater than 1. Here, so the first term is 2. Now we have to find the common ratio. Let's see. Let's do this. Let's do 6/4 divided by 2. Which would be 6/4 times by 1/2, which would be 6 over 8, which would be equal to 3/4. Right? Divided by 2, divided by 2. So I think this is equal to the ratio. The ratio is equal to 3/4. Yeah, no, that looks right. Yeah, that looks right. Okay, and so the first term is 2, so I'll say that the sum is equal to 2 over 1 minus 3/4. That would be equal to 2 over 1/4. And that would be equal to, so 2 over 1, keep, so I'll say 2 over 1, keep, change, flip. And then I get that this sum is going to be equal to 8. Why does that seem a little off? 1 divided by 1/4. No, that seems right. That's right. Okay. Again, same thing here. So I'm going to take 5 halves and I'm going to divide it by 3, which would be equal to 5 halves times by 1/3, which would be equal to 5/6. So that should be my ratio right there. That definitely does look like it right there. 5/6, 5/6. Okay. And then so the sum will be equal to 3, which is my first term, over 1 minus 5/6, which would be equal to 3 over 1 minus, 1 minus 5/6 would be 1/6. And then that would be equal to 3 for the keep, change, and then flip. So that would be equal to 18 right there. 3 divided by 1 minus 5/6. And I get 18. Alright, and that should do it for 7.4.